Okay, please turn your books to page 12 and we're going to look at sketching graphs of a straight line. Okay, so what we've done to date is we've looked at how to rearrange the equation of a line and actually formulate the equation of a line. So this is our equation, our general equation of the line. And then the last thing that you've done is just rearranged maybe to make x the subject. So we know that the value for the gradient, which is a, okay, and we know that the y-intercept is the b term, and we know that if the gradient has a number that is positive, for example 3, then it slopes up as we move from left to right, but if it, for example, had a negative number, it would slope down as we go from left to right. So when we see our equation of our line, we can start to visualize these things. So our y-intercept, it tells us from the equation of the line where it crosses the y-axis. So if we look at our general equation, we can always work that out because it tells us in the formula. So we can now learn one more step, and we can learn by using transposition how to rearrange our general equation so that we can not only get where it crosses the y-intercept, but we can also get where it crosses the x-intercept. And we do that by transposition. So when we're given, and let's have a look at this example that we've got at the bottom of the page. We've got y equals 4x plus 8. We've got our y-intercept. We've got our gradient, which is just the 4. It is not 4x, it is just the 4. It's the number. So we've got those two things that we can work out from our equation. Another way to write our y-intercept is that it's at position 0, 8. So here's 0 and here's 8. So that could be another way that you could write that rather than just the number 8. We can see that it crosses here at -2, but you might not be given that information. You're actually going to sketch that. So how do we go to do that? If you have a look here, this is your x-intercept. What is y when it crosses this line? So it's positive y or negative y. It is when y equals 0. Okay? When it crosses the y-intercept, it's when x equals 0. So let's make our equation, let's make y equal to 0. So here we go, we'll put a 0 here instead of the y, and solve it to find where it crosses the x-axis. So remembering our rules, we take anything that is added or subtracted first, take it over and change the sign. It becomes -8 equals 4x. And then the next step is anything that's multiplied, in this case, or x is divided by, we take over next. So we've got the 4 to take over. We're going to change the sign. We're going to divide both sides by 4. And so our answer is x equals -2. And that's where it is there at -2, 0. So once you've got those 2 points, you can draw them in and draw your line through them. So let's go through a couple of these examples, and so that you know how to do them, because the one in the book's sort of already been written, and it will be easier if you follow through one from the start. So looking at the top of page 13, we have all these examples. So let's go through the first one. Y equals 2x plus 5. So the first thing that we can do is we can identify, and remember, whenever you draw and sketch a graph, you only need 2 points. The y-intercept and another point, so we'll go through that example as well, or the y-intercept and the x-intercept. Okay? If it goes through the y-intercept, then that is when x equals 0. Okay, so if we look in here and we make x equal 0, 2 times 0 is 0, 0 plus 5, and there is our y-intercept of 5. To work out where it crosses our x-axis, this is when y equals 0. So to get our other point, we must make y equal to 0. And so this is where our transposition skills come into play. So the rules are, recall, anything that is added or subtracted goes first, and when you take them over to the other side of the equation, you must change the sign. The second rule is anything that's multiplied or divided, and then again change the sign when you take it over. So what have we got here? We've got a plus 5 and a 2 times x. So the plus 5 goes first and then the 2. So when we take it over, it becomes minus 5 equals 2x. And that cancels off because we're taking it over to the other side and changing the sign. And then we're left with 2 times x. So the opposite of times is divide. We're going to divide both sides by 2. And then the 2's cancel on the right-hand side. And the convention is to be x equals, and so we both know that both sides are equal, so we can just swap them over. And our x, where it crosses our x-axis, is at minus 2.5, 0. So now we've got our 2 points. We just draw our little axes. So when you are sketching, it's easier for you than me on the tablet to use a ruler. And I want you to make sure you get a really good scale across here. So let's have a look. What have we got? Our y-intercept is 0, 5. So count it out. 1, 2, 3, 4, 5. Make sure they're even. Label it, the number, so that you've got a scale on your y-axis. And that would be minus 1, minus 2, minus 3, etc. And then your x-axis doesn't have to be the same scale, but it could be in these cases, as long as you're consistent each way. So if that amount is worth 1 unit, then that amount must be worth 1 unit, okay? As long as you're consistent. So we've got to get to minus 2.5. So 1, 2, 3, and so halfway between minus 2 and minus 3 is there, and then you can draw a line between those points and extending either side as well. So there's the first example. Let's just do one more of these. We might do this one over here. Y equals minus 4x plus 8. So what are the steps? Work out where it crosses your y-intercept. So you can easily find that from the equation, and you should be quite confident now after doing all those problems that you can identify the number that is added. In all these cases are added, or subtracted to the x is our y-intercept. So our y-intercept equals 8, or you could write that as 0, 8. So we know that it crosses 2, 4, 6, 8. We know it's going to cross there. It says minus 4x, so I'm imagining that it's going to slope down like that. The next step is to work out where it crosses here on the x-axis. So this is when y equals 0. So we're going to substitute y equals 0 and then transpose. So that means rearrange the equation so that we're going to get x by itself. So we've got a plus 8 that we're going to take over first and change the sign. And then we've got this minus 4 that we're going to take over and change the sign as well. So minus 4. Just remember when you take it over, you take the signs as well. So it's minus 4. And that just make sure that x becomes positive. Minus divided by minus makes a positive, and 8 divided by 4 is 2. And then, because I've run out of space, x equals 2. And so the coordinate point would be 2, 0. So where would it be? So let's make that 2, 4. Here's the 2, 0. And then you would have a line running down through there and past each of the points. So you've sketched the graph. You only need 2 points technically if you get the values correct. And there's just one exception here. Let's have a look at this exception before. I think this one's very similar to one we've already done. So let's look at y equals 3x. So in this case, we don't have a clear y-intercept because remember, it's one of those exceptions we looked at on the bottom of page 11, okay, where it's plus 0. So that means the y-intercept goes through the origin at this point. And so if you were going to sketch this, okay, it would be very difficult to work out what the x and the y, because it goes directly through here. So if you see an example like that, instead of making y equal 0 or x equal to 0, the answer is going to end up being 0, just make x another value. So 3 times 1, let's call it 1. Let's substitute in 1. What does that make us for y? So 3 times 1 is 3. So that means when x equals 1, y equals 3. And so let's put that in there. And so it would go through the origin and look something like that. But obviously that would be ruled on yours. So there are a few exceptions. So let's go through those exceptions now. The special cases. There are some graphs worth remembering. Okay. So let's just pause. Okay, so let's look at these special exceptions. Y equals x. So that means if x equals 1, y is going to equal 1. If x is equal to 2, y will equal 2. So it might look, if you were plotting the points, something like that. And then you would draw your line through it. Y equals ax. So we've just got a gradient. We don't have our y-intercept. So that's like the last example we looked at, where you will have your line going through the origin. Similar example, but we've got a negative. Okay, so it's y equals negative 5x. So the number's bigger, so it's going to be steeper. So it might look something like that with a straight line. Let's look at y equals b. Okay, so the y equals 4. So that's an example where there's no gradient. Remember, in our general equation, if the gradient is 0, then y equals the y-intercept. So if it's 4, it will just have a horizontal line like that marking in the point. And then the last one is when x equals our particular number, okay? And so if we have a look at this, x equals minus 2, it means for every value of y, all the way up here and down there, x equals minus 2. So there's some of the exceptions you might come across, okay? So what I would like you to do is have a go at those, and when you have, I would like you on page 40, questions 11 and 12. Now questions 11 and 12, the first one, the line between 2 points, and then, sorry, let's take that away, is question 11, which is sketching the graph, okay? And then question 12 is using a graphics